Alright, in the last podcast we did some test runs with Telnet and SSH to our routers, and then we added in the packet sniffer so we can start examining the Telnet and SSH traffic. So this part, let's examine the Telnet and SSH traffic. So let's set up this side here, let's set up this sniffer over here to examine Telnet traffic, and then we'll get some Telnet traffic moving through it. So I'm going to click on this sniffer, go to the GUI tab. I'm going to make sure the port 0 selected is incoming so it receives the packets. I'm going to basically shut off all protocols. I don't want to see any other protocols. I'm going to do edit filters under miscellaneous, and I just want to see Telnet on this side. I'll close that and I'll clear all the packets. Okay. Now, just to clean up my screen, I'm going to close this. You can leave yours open if you wish. We're now going to get some Telnet traffic through this part of the network so the sniffer picks it up. So I'm going to Telnet into my Harrisburg router up here. So Harrisburg PC, open up my Telnet SSH client. I'm going to select Telnet, and I'm going to plug in the IP of that router, 192.168.100.1. I'll do connect. Remember, the username I configured was Doug. The password on this guy is password. Yeah, it looks like something got pasted in there, so I'll say Doug for the username, password of password. There we go. It's odd that it's doing that. We'll do enable, class, and we'll do a show run. And just generate some Telnet traffic through here. Alright? Looking good, looking good. I'm just going to close this session out. I'll do exit. Oh, come on. And I'll do exit. There we go. I don't want to reestablish a new session, so I'll close that out. That should have generated some Telnet traffic for my sniffer. So I'm going to open that up, and there is a whole bunch of Telnet traffic, a whole bunch of it. Oops. Okay, so let's look at the first packet or two up here. I'm going to highlight that, and I'm going to look at the contents over here on the right side of the window. And I'll make this larger. There we go. I'm going to scroll right to the IP header. Source is 100.1, destination is 100.10. So this first Telnet packet is from the router coming back to me. I'm going to scroll down through. I'll see the source port is 23. 23 is Telnet. The destination port is 1028. That's the port that my application, my Telnet SSH application, happens to be using. Scrolling down a little further, I'll see Telnet data. This is where it says, hey, what's your username? I'm going to click the next packet, and I should hopefully see things flip-flop. The source is now 100.10, which is me, 100.1, which is the router. Source port is 1028, which my application is using. Destination is 23, which is Telnet for the router, or Telnet. Scrolling down through, my data is D, because I started typing the username Doug. I'm going to click down through a couple of these, and I'm going to look at the data. There's D, O, U, G. So there was kind of like packet by packet, me sending my username to the router. If I keep going, what I should eventually see is, let's go down here a little further. There's the username. We had a repeat there for some reason. I'm going to keep going. Username, I'll go down a little further. There's A. There's S. So there's finally me typing in the password of password. There's S. A little further. W. Oh, so there's me typing in the word password. What I think we're recognizing here is every keystroke, if you will, is getting sent to the router as like a packet and a response is coming back. But I'm also seeing that my data being sent to the router and back is in clear text. It's not encrypted. So if I were able to capture these Telnet packets and just kind of filter through them, I would start gleaning usernames and passwords from them. And that is one of the problems with Telnet. That's why Telnet's kind of old school. I'm putting little air quotes around it. It's old school and pretty much not used because of this security problem. All right, so there's my Telnet. There's my Telnet data from this side of the network. Let's do the same process on the other side. And actually, here's where I was having you look at the source and destination IP, source and destination port, and then looking at the data. Well, let's do the same thing on the other side with SSH. So let's open the sniffer, GUI, port 0. Let's show none of our packets or none of our protocols. Let's edit, and we're going to go to miscellaneous, and we're going to go SSH. Again, I don't want to see anything else. I just want to see this SSH connection, if you will. Clear all the packets. You can leave yours open. I'm going to close mine for decluttering my screen. I'm going to close mine to declutter the screen. Sorry, I had a sneeze there, so I paused so you didn't have to hear the sneeze. All right. I'm going to open up my Philadelphia PC. Telnet SSH client. I'm going to leave SSH. I'm going to plug in the IP of the router, 172.32.0.1. Username of Doug. I'm going to connect. I'm going to use password of password. I am into the router. Class. Show run. And I'm in the router working on it. Alright, I'm going to exit out this connection. I do not want to reestablish, so I'm going to close all of this. And now I'm going to go look at my sniffer with the SSH traffic. And there's a whole bunch of SSH traffic. All right, let's look at the first packet or two, just like we did on the Telnet side. Source IP 32.1. So this is the router coming back to me. Source port is 22, which is the port for SSH. Good. Destination port is 1026. That's what happened. That's the port that my Telnet SSH client application is using at present. Scrolling down through, let's look at the data. It says encrypted data. All right, let's keep going. Here is router to me. Encrypted data. Here is router to me again. We'll keep going until we see maybe the other way around. Here's me to router. Okay. So we see the ports. There's my SSH client to the router 22 Telnet. Let's keep going. Let's see what we see down here. Encrypted data. Okay. So I'm going to go down. I'm going to spot check a couple of these. Encrypted data. Let's go a little further. Spot check. Encrypted data. Oh, yeah. SSH is a secure shell. So I should be expecting to see encrypted data. I've captured it all, but it's encrypted, so I can't see what's actually in there. I'll keep going down here, encrypted data. Keep going down here, encrypted data. Yeah, that's exactly what I'm going to find. Even if this were in a real live network, I could capture them all. I could see the packets, but if I try to open and look at the data, I'm not going to be able to interpret what it is. It is encrypted, which is the whole point of us when we set it up, doing the crypto key generate RSA and setting up that encryption key that when we connect, the communication from my client to the router was encrypted. So here, as I look at the SSH traffic, I'm seeing the source and destination IP and port, and then as I look at the data field, I'm seeing the data, but it is encrypted, so I can't actually read the data. All right. Feel free to do some more Telnet SSH sessions here to work with your network. Maybe save your packet tracer file before you get too much further. And now let's gather, once you're done with that, let's gather our configurations for submission to D2L. So I'll open my Harrisburg router terminal connection, and I'm going to do enable class, show run. I need to save this config for submission to D2L. So I will highlight all this, scroll down, scroll down, scroll down, right-click copy. I'll open up a new notepad file, so I'll say new, 125, remote, brown, and I'll say in here, this is my Harrisburg router config. Something to that effect. I'll paste it in. I'll save this guy. Remember to leave the TXT file extension, 125. I'll call it remote, and I'll call it like Harrisburg router or Harrisburg config, something like that. That way I know that this is the, actually I'll put in there Harrisburg router config. There we go. And that way I know what that is. And we'll save that. I'm going to do the same thing for the Philadelphia side. Console in, terminal. Let's do enable, class, show run. Make sure I get it all. Highlight and copy here. Scroll down. Right click copy. I'll open up a new text file here. So new 125 remote lab, and this is my Philadelphia router config. I will paste that in, save, and just like before, 125 remote, and I will call this Philly router config. Oh my goodness. There we go. And now I have, there's my Harrisburg router, there's my Philadelphia router. If I didn't do it already, make sure you save your packet tracer file. So I have that. Before you go any further, I'm going to scroll down here. Make sure on the submission area I have my routing table, and if I didn't get it previously, go back and get it now. Oops, I don't want command prompt, I actually want terminal. Do show IP route, and this is where you should be seeing all three networks. If need be, get this now if you forgot it before. Save that. Make sure you have the Harrisburg config or 2011 and the Philly config or the 4321 and your packet tracer file. And then we have some questions to do. So make sure you have those, and this is where I'll go to my folder I've been saving my files in. There's my Harrisburg router. There's my remote lab. This is actually my routing table. I should actually probably call this routing table. Remote lab. I'll call this routing table. That way I know that's what it is. There we go. Yeah, if I open that guy up, I will see him there. There is my routing table. Yeah, I didn't name him too well before. So routing table, Philadelphia router, Harrisburg router, good. I have my packet tracer file. I called this one demo 2, but there's my packet tracer file. The only thing left are my questions. So at this point I could close my packet tracer if I wanted to. With my questions, I have 5 questions here. How is remote access to a router or device like a switch useful in a network? Hopefully you saw. If I have it configured on my devices, I could be sitting here in Harrisburg and remote into a device in Philly, whether it be router or switch, could be server too, and potentially work on it, update it, fix it, repair it, help somebody else troubleshoot it, and not actually have to physically go there, physically drive there. TCP port number for Telnet. Hopefully you remember that from seeing your packet tracer. And what was the problem with Telnet? Hopefully you remember seeing as we were looking at Telnet. Everything was clear text. Yeah, that's the problem. TCP port number for SSH. Hopefully you remember seeing that. If not, look it up. And why is SSH preferred? Well, hopefully you remember everything was encrypted. So my data is a little bit more secure with my data moving across my network is more secure. It's not as easy to compromise. All right. Make sure you have all those files and all these questions saved and get them submitted to D2L.